always a great pleasure for me to be here in Belgrade. My presentation will be a long-term experience in managing a transboundary deep groundwater body, and it's not so easy to have 15 minutes to give all the experience of a time period for more than 20 years. And yesterday, Nemo Kukuruc told us the management principles for transboundary groundwater bodies in theory, and now I try to give you an overview about the experience we made in field, in practice, with these principles. So what's the contents of my presentation? My slides my wife don't see, and so I must not start with the conclusions. First, to give you a short introduction about the situation where we are, about the hydrogeological situation, and also about the legal frame in which we do our work. Then, the focal point about the main strategies, and at the end, conclusions. So where we are, that's Austria. It's a mountainous country, and in one part of it, it's in the northwest, there's a deep groundwater body between Austria and Germany. It's about an area about 5,900 square kilometers, with a length of approximately 150 kilometers and a wide from 60 kilometers. It is a karstic German groundwater body, and it stands up from the northwest to the southeast. The deep was from a few hundred meters up to more than 2,000 meters, and there was a step fault, and when the aquifer gets deeper, also the temperature will rise up, and the temperature was in the surface near aquifer about 20 to 30 degrees, and in the deepest parts more than 120 degrees. So what are the problems from this groundwater body? There was an intensive use on both sides of the border. Especially on the German side it was spa use, and on the Austrian side it was hydrogeothermal use. And this use will increase more and more, and the demand for the water increase also, and they become problems. This decreasing from water abstraction means that it was a decreasing for the observed water pressure, and this means that it was less water for the users and also higher cost for them when they needed to pump it. So it was a transboundary groundwater body, and there are different and special renderings. It was a different legal regulations on both sides of the border. You have different administration structures. You had different interests. As I mentioned, it was spa on one side and the use for energy on the other side. And this was also from important, different culture to solve the problems. So to show you the problem, it was the pressure head in one of these spas in Germany, and you see the decreasing pressure from 1975 until near 2000. So what was the legal frame for work? It was the Regensburg Treaty. It was an international treaty on water management in cooperation in the Danube River Basin. It was a bilateral treatment between Austria and Germany, and it was established in 1987. And this treaty mentioned also a permanent bilateral water commission between Austria and Germany, and under the frame of this commission it was instructed an expert group called Thermal Water, and this expert group was installed 1992. a time long before the WFD became in force. What was the duty of this group? To supervise the elaboration of a groundwater model, to make proposals on how to manage the groundwater resources, management strategies, and to lead and accompany the management. So what were these management strategies? First, you must have knowledge about your field in which you are working. So we try to get some investigations and studies. Then the next one is the exchange of the relevant information and data between Austria and Germany, both sides, to elaborate guideline papers, how to use the water, how to manage it. Then also to elaborate a monitoring system, data collection and data reporting. And as a very important strategy for us in our groundwater body was the application and the maintenance and further development of a mathematical groundwater model. I will point it out later. And also a common determination for the qualitative and quantitative status according to the WFD. This point will become later. So what are the investigation and studies? As I mentioned, it was a groundwater body wide from 5.9 thousand square kilometers. And we only had few points, I think it was about 15 boreholes in this area. So it was not easy to get some more, can't get more information, but it was very difficult to elaborate how it can be the field from the pressure, from the water flow and so on. And therefore it was necessary to elaborate a hydrogeological model and conceptual model. It was at the beginning of the end in 1996. And based on this model, a 2D mathematical groundwater model was worked out. And this model is now, until now, the basis for the water management here for this deep groundwater body. But we don't stop our work. We are going further on and try to get more information and to make more studies to get a better knowledge about the groundwater model. And therefore, we have an international workshop in Munich 2002. We tried to get a hydric thermal command groundwater model 2007. It was not a model for the whole area. It was only one part. It is to get one of the system reaction for extraction when we change it. Then we have a deficit analysis study 2002. This shows us that the model from 1998 still was working well, but in the meantime we get more information about the groundwater body, new boreholes, and the results of these boreholes shows us that it was necessary to overwork our model, and therefore now at the moment we have a revision of the hydrogeological and mathematical groundwater model. So you see the work is going further on, and we don't stop it. We try going on step by step to get more knowledge about the groundwater body. Also in this expert group, it was an exchange of information. It was very, very important. And in this expert group was a report about the current development, about planned projects, and also about the collected data, and the experience with the guideline papers. I forgot to say that this expert group has 3 or 4 meetings per year, and in these meetings all these informations exchanged were done. And this exchange of information are the basic to prepare further investigations. We see, as a result, we see that we have to overwork our groundwater model, and also the information to a wider audience, public information. So, this expert group has brought out guideline papers, and there are the principal chapters were management principle, the dimensioning of plans for the thermal water use, the required application documents, a catalog for requirements for the emissions, and the model application. And these guidelines are the basis for the authorities on both sides of the border when they give a license to extract water. So, also the data management and reporting, as I said, this data information exchange was in the group, but you have to get the data, and the principle is you need these data for a sufficient management. You can't do any management without data. Therefore, you need a comprehensive monitoring system and a combined and harmonized monitoring program from both sides. And for a deep groundwater body, it's not so easy, because it's extremely difficult to get these information. It is very expensive to establish measurement sites, and it's also complicated. So normally existing boreholes were used, and the measurements and sampling were done by private operators. We are in the lucky situation that several years ago we get the chance to have one borehole that was not used to implement in our monitoring system. So we have one point for an area about nearly 60,000 hectometers without influence from abstraction from our monitoring. So, and these data were collected by the companies and validated, analyzed, and interpreted. It must be, then they have to compare it. And therefore, it is needed for an annual status report and comprehensive to summarize it in 5 years as special reports. And this was accessible to the administration. So, as I mentioned out, this mathematical groundwater model has a very important status here for the management. It evaluates the required water extraction. It has for prognosis for the management and statement about existing thermal water use, and it was the basis for water law approval processes on both sides. And I think that it's not so often that on both sides you have a common groundwater model. And in this guideline that I mentioned was the application, maintenance, and further development of this groundwater model. Here I want to show on this short slide the results of the common management. You see before, until 2000, it was decreasing, and after the common management with all these strategies we use, it rise up, and now at the moment it's stable. It's going. We have no problem with pressure on the soils. So, but what is very important to go further on, not to stop here at that point, because it's needed the management for a long time. So, what's the conclusion? It's in the first step, you have the socio-economic and institutional aspects. You have the identification of the problem. We have installed an expert group and find a common approach to solve the problem. And the cooperation between administration, expert groups, and science are very, very important, also for the future. It's also you have hydrogeological aspects. You have the delineation and description of the groundwater body, data collection, and you have have to make models, hydrogeological models, conceptual models, or groundwater models. And also you have to take into account legal aspects, the legal and institutional cooperation, guidelines, management and protection, and recommendations for the use in the guidelines. So it's very important for a transboundary groundwater body to get all shareholders into a boat, to point it out the common interest, the interest of the users of the resources, and also of the authorities on both sides. And if this is possible, I think that it's also possible to have a sustainable use for a long period. Okay, I want at this point acknowledge to my colleagues in the working group and the colleagues in the ministry.
Yes, thank you very much.